In this lesson, we are going to learn about Simulink. Previously, we have covered several chapters in MATLAB. Now we are going into Simulink. So to launch Simulink, you must open MATLAB, and the command to launch Simulink is simply by typing in Simulink, and when you press enter, you will see the Simulink start page being displayed. Or the easier way to launch Simulink is simply by clicking the Simulink icon, which can be found in the home button in the MATLAB application. So by clicking here, the Simulink start page will be displayed. So we want to start with creating a blank model. So if you click on blank model, then you will see an untitled Simulink document will be created, and we want to click here for the library browser. When you click on the library browser, you will see the Simulink blocks that you can use to create the Simulink block diagram. So we have a few types of Simulink block libraries. The commonly used blocks, continuous blocks, dashboards, and so on. So I'm gonna demonstrate the simplest Simulink block diagram. We want to go to the sources. From the sources blocks, we can put in the source or the signals that we can supply to the Simulink program. So whenever you find a block and you want to know further about the block, you can always right click on the block and click on help for this block, and MATLAB will open a documentation where you can read the description and how the block can be used in Simulink. So let's first use the sine wave here. So what we're going to do is by click and drag it into the Simulink window here, and you can provide the amplitude, or you can simply leave it blank, and the amplitude will automatically set as 1 if you leave it blank. And this is the source, and to display the output, we are going to go into the sinks library, where you can find a lot of outputs that can be displayed. So here the most commonly used one is the scope here. So you want to drag the scope into the Simulink window, and Simulink asks how many number of input ports that we want. You can simply leave it blank, so the default number of ports is 1. Or you can type in, for example, if you put in 3, you press enter, you will see that 3 inputs. You can always resize this, and you can see 3 inputs being displayed here. So you can connect up to 3 inputs. So we want to double click in here, or you want to right click, and you can go to signals and ports and set the number of input again to 1. So we have 1 input here. I'm going to resize it again, and we can, when you bring the scope closer to the sine wave, Simulink give a suggestion that these two can be connected. So you can simply click on it, and these two has been connected. So when you double click on the scope, it will display the scope, and you can press the play button here, the run button here, or you can also press the run button over here. So when we press the run button, we can see that the sine wave is now being displayed. And you see down here, the sampling time is 10 seconds. This can be changed from the Simulink window here. You can drag it, make it a bit larger, and you can see 10. The number 10 here is the simulation stop time. So if we want to simulate up to, let's say, 30 seconds, we can always change this to 30, hit enter, and when you go and run this again, this will be run for 30 seconds. And here you see that the curve is not so smooth. It is very coarse. There are a few sharp edges here. So this is because the step time that we need to define in order to get a smoother curve. So this can be done by going to the model configuration parameters. Click on here. And we have to wait until the configuration parameters comes up. And we will go into these additional options under solver here. Just click on the arrow. And you see that maximum step size here has been set to auto. So basically MATLAB and Simulink will automatically calculate the maximum step size. But we want to change this into, for example, 0.01 in order to get a smoother curve. So we press OK. And we go back here and run it again. And you will see a smoother curve. Okay. Now let's go to the commonly used blocks. We can include a gain, for example, here. Just want to show you that we can input several signals into the scope. So let's say I want to gain by 3. So I enter the number 3 here. So this will change here. You can always change the gain coefficient by double clicking on the gain and set what is the value for the gain here. So here we set 3, and then and we want to delete this line first, this connection, and we want to bring the bus creator in. So now we want to connect the bus creator to the scope, and the sine wave will be connected to the first input. Okay, and now we want to connect this output of the gain to the bus creator as well, so that 2 signals will be displayed. And we want to connect now the sine wave to the gain, so that the output of the sine wave will be displayed in the scope, and also the output of sine wave will be multiplied with 3, then will also be displayed in the scope. So to create a branch of this arrow here, we click on we press Control and click on the arrow, on the line, and the branch will be created, and you just simply connect it to the gain. So when we double click on the scope now and press run, we will see that this is the yellow curve is the original sine wave, and the blue curve is the one that has been multiplied by 3, and you can see the amplitude of the sine wave is now 3. Okay. In previous chapter, the symbolic maths, we have learned how to solve simultaneous algebraic equations. So let's do some recap. In symbolic math, to solve simultaneous equation, first we need to define the symbolic objects. Let's say we have sims of x, y, and z. And then we define the equations. Let's say equation 1 is 2x plus 3y minus 4z equals to minus 6. We have equation 2 that is equal to 4x minus y plus 2z equals to 3. And equation 3 minus 5x plus 2y minus 2z equals to minus 2. To solve these 3 equations using symbolic maths toolbox, we can use the solve function by, for example, using the structural method. So an is equal to solve of EQ1, EQ2, EQ3, and we press enter. We got a structural answer with fields So if we want to see what is the value of x, we can simply type in double of an dot x. This is the value of approximated value of x. This is approximated value of y, and finally the approximated value of z, that is equal to 2.1364. So this is how we solve this simultaneous equations, algebraic equations, using MATLAB Symbolic toolbox. Now we want to solve this equation using Simulink. Let's see how can we do that. First, we create a blank model. So we have a blank model here, and we open this library browser simply by clicking on here, library browser. This will be opened. So now we're gonna drag a few blocks into this blank Simulink model to solve these three equations here. So to begin solving this equation, we need to go to the math operations library, double click on this, and you can see this algebraic constraint block. So you want to drag this into the model, and this will be used to solve these three equations here. And in addition to the algebraic constraint block, we also gonna need this add block. And before we add this block into the model, we see here that we have a few terms, 2x, 3y, minus 4z, and minus 6. So basically for one equation, we have four terms. So we're going to drag the add block in the model. And here, list of signs, I prefer to use all positive signs. So since we have four terms, we're going to put four pluses, four plus signs, plus, 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 plus. When you press enter, you can see that the input now becomes 4 with everything is a plus. So we're going to bring this closer to the algebraic constraint and connect them together. Okay, now we see that we have a few terms here. The first one is 2x. So 2 is basically the coefficient of x. So this can be represented by the gain block. So we're going to drag the gain block in here, and it asks for the number. You simply put 2. So this change into 2, and you're going to connect this to the first entry of the add block. The second one is 3y. We can drag the gain block again, and now type in 3 and connect them together. Okay, and then we're going to drag the third gain block. This will represent minus 4z. So here we type in minus 4, press enter, you see minus 4 appears here. So you now connect them together as well. Okay, so we can arrange this nicely. And the last one is minus 6. This is not a gain because it is not multiplied with any variable. So this is simply a constant. So you can drag this constant block in here, and then the value is simply minus 6. Then you want to connect it to this last entry of the add block. Okay, now you can highlight all of this block and right click on it and go to format, untick show block name, because we don't want the gain and constant to appear. We just want to see the numbers. So basically now we have 2, 3, minus 4, and minus 6 connected to this add block. Now the output, we want to go to the sinks library here and drag the display block. This will display the answer. Okay, now we're going to connect this and drag it away a little bit. So this will be the output of all of this. And the first output will represent the answer for the value of x. So you can double click on the connecting line here on the arrow, and you can then type anything that you want. I want to label that this output here is the X value, so I put X here. So now we have three equations. The first blocks here, group of blocks, represent the first equation. Now we're going to highlight all of this, and to duplicate all of this to create the second equation, we can simply press Ctrl and drag all of this. This will duplicate the blocks. So press Ctrl on your keyboard and simply drag it down. You'll see that now this has been duplicated, and we can duplicate it again. Hold down Ctrl button and then drag it down. You'll see that it has been duplicated. Okay, now we can rearrange this. Okay. Now, if this output is X, this will be Y, and the last output will be Z. Okay, now we have to change this coefficient here. For second equation, it is 4x, so this will be 4. This will be minus y, so minus 1. Here becomes 2, and here double click and replace it by 3. The last equation is minus 5. This one is 2. This one is minus 2, and the last one is also minus 2. Okay, this is not finished yet. Now, if this output is X, now we need to, you see that the gain blocks here, you need to supply an input to this. So basically this 2 is a multiplication of X. See here, the first equation is 2x. So now we want to drag, or we want to make a branch out of this, because this output is X. We want to make a branch and connect it to this gain block of 2. So remember from my previous lesson that to create a branch, we hold down the Control button and click on the line, and this will appear, and you want to connect it to this number 2 constant. Okay, that is the first branch. The same goes to here, 4 down here. For equation 2, 4 is multiplied with x. So we want to create another branch. Hold down Control, drag it into 4. So this will be the second equation. And for the third equation, we can create a branch from here. Hold down the Control button and click and drag it to minus 5. Minus 5 is a multiplication of x as well. So now x has been connected to 2, 4, and minus 5. Now we do the same for y. Y is to be multiplied with this 3 gain here. So create a branch out of y, connect it to 3, and you can arrange it nicely over there. And drag another branch, connect to minus 1 here. And you want to drag a branch out of this, connect to 2. That is the output of y. And now we do the same for z. Drag a branch of z, connect it to 4. You can drag it over here. And we want to create a branch here, connect it to 2. And we want to create a branch here, connect to this 2 here. So everything has been connected. Now we can just simply press run here and see the output, and the output is similar to what we have in MATLAB here. For the first one is something is wrong. 2, 3 minus 4, 4 minus 1, 2 minus 5, 2 minus 2. Oh, here we cannot put minus 6. We need to bring this to the left hand side. So this actually becomes 6. And this one also we want to bring it to the left hand side. So this becomes minus 3. and this bring to the left hand side becomes 2. So when we hit run again, we will get minus 0.909091. This is equivalent to this for x, for the answer of x. Y, we get 0.9091 for y and 2.136 for z. So that is how we solve simultaneous equations or algebraic equations using Simulink instead of using the Symbolic toolbox in MATLAB. So you have two options. It's either you use MATLAB or you can also use Simulink. Sometimes Simulink can be helpful. Sometimes it is easier to use MATLAB to solve the algebraic equations.